Hello everyone and welcome to the composite clustering of non-relational data with mixed types using K-modes and K-prototypes by Makram Janedi and Khaled Bendriz. Both the authors, Khaled Bendriz, CTO at WaveView, and myself, data scientist at the WaveView Labs team. So first of all, we're going to talk about clustering in general, which is the process of grouping a set of observations or items into subsets that we might call clusters. And we're going to focus on the partitioning clustering methods like the well-known K-means, K and its variations like K-medians, K-medians, K-modes, and K-prototypes. So these variations use the same process of initialization, assignment, updating centroids, and repeating the second and the third step until conversions. Also, they use the same process of minimizing a cost function. So the main differences between these variations are in initialization using random centroids or choosing from data points. Also, the centroids might be the means, the medians, the midweights, the modes, or even the prototypes. And for the distances used, they might use the Euclidean distance, the Hamming distance in the case of K-modes, or even a combination of both in the case of K-prototype. So we might sometimes be dealing with special cases like working with mixed data types where we have continuous and categorical attributes in our data set, or for example, working with the non-relational data, like in the example below, which is a well-known JSON format, a key value JSON format. But sometimes we might have some keys like required that might have multiple values. So the possible solutions for these use cases are, for mixed data types, we might use K-prototypes algorithm. For the non-relational data with multi-valued attributes, we might use aggregations, like aggregating, like using the mean, the max, or the minimum of the continuous labels, or the mode of categorical labels. Also, we might use the mapping of a NoSQL database into a SQL database, which is not a good solution actually. And we also can encode the categorical attributes into dummy features. And this will create a high dimensional space. And we're going to be using a PCA, for example, to reduce the dimensionality. And finally, this is another good solution, like described in the article of Huang, while he compared K-prototypes to using PCA followed by K-means. Also, we can use the word-to-vec. It's a good solution, but finally, we cannot assign multiple clusters to a single label. We will explain this later in the following sections. So our methodology proposes a solution for the multi-valued non-relational data with mixed types using a composite two-step clustering method based on K-modes and K-prototypes algorithms. So we used K-modes in the first step to create clusters from labels of the multi-valued categorical attribute. And then we used a voting system that will assign a unique value for each multi-valued attribute, initially multi-valued attribute. So this is achieved by replacing every value in the list of labels of that multi-valued key by the cluster it belongs to. Then we can extract the most represented cluster, which will be the unique value, and it will be assigned to that key. In the second step, we use the K-prototypes algorithm to cluster individuals or objects in our dataset using the continuous, the categorical, and the preprocessed attributes from step one. So before moving on with explaining our method, we will be defining some conventions that we will be using later. So by attribute, we mean, for example, properties, type, title, or required. So for example, required is the type of variables we will be dealing with in the first step of K-modes. It has an array, a list of labels, a list of values. Here in the example, it has 2 values, but we might have an attribute with hundreds of values. So these are called labels. And the whole document, we will call it object. Step 1, which is the K-modes algorithm, is based on creating a new flatnet dataset where columns are the mentioned labels of one multi-valued attribute. We will call it here target attribute across all objects. And rows are the object IDs or indexes. So if we go back to the previous example, the required attribute will be our target variable, which is a multi-valued key. And the rows will be the object IDs. The columns will be the labels of the attribute required across all the objects of the dataset. And then for each object, if a label is mentioned in the target attributes list of values, a tag 1 will be assigned to the corresponding object label index in the created dataset. Else, the default value will be 0. And then we will implement a k-modes algorithm that considers the values 0 and 1 as categories. And this will generate clusters of objects. Here's an example that illustrates how the flattened dataset will look like. As we mentioned previously, the columns are existing labels in the multi-valued attribute across all objects. So for example, for object 1, it is mentioned in the multi-valued attribute. It is mentioned in the label 1 and label 3 in its list of values. So before we move on, I would like to remind you that after this, we implemented a k-modes algorithm that considers the values of 0 and 1 as categories, which will generate initial clusters of objects. So when we analyze the mode of each created cluster of objects, which is a vector of modes, this is how k-modes work. And we extract which variables of the modes vector that have the value of 1. I'd like to remind you that in our flattened dataset, the variables can take either 0 or 1 as values. So the mode of each variable can be either 0 or 1. And we extract the variables that have the value of 1 in the modes vector. Then we will be able to generate new groups of labels. This is the main idea in our step 1 of our method. So I will illustrate it more with this example. If the generated clusters are the following 3, and we look at the mode of the cluster 1, the green one, the mode of this cluster is the following vector, then we will be able to say that label 1, label 4, label 5, and label 8 can belong to the same group of labels. Reminding you again that these are the variables of our flattened dataset. So this step also allows a label to belong to multiple groups at the same time. Before moving on, I would like to remind you of the process of step 1, which is to create clusters from labels of multi-valued categorical attribute. Then the sub-step 2, which is to implement a voting system that is able to assign a unique value instead of a list of values for a certain multi-valued key. So how is this done? If we take an example, this object as an example, which has the following multi-valued key with label 1, label 2, label 3, 4, and 5. And after we implemented the k-modes algorithm and generated the clusters of labels, we found out that label 3 belongs to cluster 2, label 4 to cluster 2, label 2 also belongs to cluster 2, and we found out that label 5, for example, belongs to cluster 3 and 1 at the same time. So what the voting system does, it replaces the multi-values, the list of values by a unique value, which is cluster 2, which is the cluster that is most represented in the list of values of that categorical key. What I would like to note here is that we may not have only one categorical multi-valued attribute, but we may have multiple ones. So the same process can be applied on all of these attributes to make them single valued. Next, the preprocessed data, along with our continuous and categorical attributes from our initial data set, can be passed to a k-prototypes algorithm to generate clusters of objects. Next, we will be presenting an evaluation of our methodology on real-world data, where we aim to cluster applicants based on their resumes. So the pipeline goes from extracting the resumes into a raw collection, then creating a pre-processed collection where we performed some cleanings, standardizations, feature engineering. So the variables, some of the variables of this pre-processed collection are years of experience, for example, number of skills, number of projects, number of certifications, and a multi-valued attribute, which is skills. So we need to apply k-modes to make the skills attribute single valued. Then we pass all these pre-processed, continuous, and categorical skills to a k-prototypes algorithm to perform and to generate new clusters. So during the k-mode step, we aim to generate clusters of skills and to make the skills attribute single valued. For this, we use the following cost function and an elbow method that will help us to choose the optimal k number of clusters, which is an important parameter in every partitioning clustering method. So the following cost function sums the dissimilarities between points of each cluster. Based on the results that we got from the elbow method, the chosen optimal number of clusters to use is 25. Some of the generated clusters of skills are, for example, the first one that contains Java, SQL, Linux, Python, machine learning, Hadoop, big data, Spark, that we can name it AI and big data. Also the second one, for example, that contains Java, Hibernate, Spring, Maven, Scrum, and that we can name it software engineering. And another example that contains project management, strategy, business strategy, and we can name it project management. Also, we can see that there are some skills that belong to multiple clusters at the same time. Before moving to the next step, which is the k-prototype step, I would like to mention that we applied the same voting system in our multi-valued skills attribute and transformed it into a single valued one based on the generated clusters from the k-mode step. Next, we use our preprocessed attribute along with our categorical and continuous variables from the initial dataset. We passed them to a k-prototypes algorithm and generated clusters of applicants. To be able to visualize and make interpretations of our k-prototypes clusters, we implemented the PCA and used the first two components to make a plot of our clusters. To identify these components, we used the contribution of initial variables to each one of these two components. So we found out that the first one is more related with seniority and employment. However, the second one is linked with technologies and experience acquired. Some of the interpretations that we made are, for example, the cluster one contains applicants with less seniority and less technical experience than those of cluster 0. So to summarize the process of our method, if we start with a non-relational data with mixed types, we can apply k-modes and a voting system to transform the multi-valued attributes into single-valued ones. Then we can apply k-prototypes to generate clusters of objects. For future work, we can do some optimizations of k-modes and k-prototypes. Also, we can optimize our process, and we can think about a profile recommendation system, which can propose the most suitable applicants for specific demanded profile. Thank you very much for your attention.